Welcome to Section 4, Lesson 5. In the previous lesson, we worked with the slope-intercept form y equals mx plus b, which uses the y-intercept as the anchor point of the line. Today, we add a second canonical form for the equation of a line point, slope form, written as y minus y1 equals m times the quantity x minus x1. The point-slope form uses any specific point on the line as the anchor rather than restricting to the y-intercept, which makes it more flexible than slope-intercept whenever the y-intercept is unknown or inconvenient. Today, we lock in the point-slope formula, the procedure for using it, and the conversion between point-slope and slope-intercept forms. First idea on the board. The point-slope form of a line with slope m passing through a specific point x1, y1 is the equation y minus y1 equals m times the quantity x minus x1. The form follows directly from the definition of slope. The slope between the anchor point x1, y1 and any other point x, y on the line is the same value m. Setting up the slope equation y minus y1 over x minus x1 equals m and clearing the denominator produces the point-slope form. Second idea. Point-slope form is more flexible than slope-intercept form because the anchor point can be any point on the line, not just the y-intercept. If you are given a slope and a non-intercept point on the line, you can write the equation in point-slope form by direct substitution into the formula, without needing to compute the y-intercept first. The point-slope form is also more natural for many real-world scenarios where a starting point is known but does not happen to be the y-axis crossing. Third idea. Point-slope form converts easily into slope-intercept form by distributing the slope across the parentheses and rearranging to isolate y on the left side. The conversion takes about 5 seconds and is useful when the problem asks for the slope-intercept form specifically or when you want to read the y-intercept directly from the equation. The two forms describe the exact same line. They are just two different algebraic expressions of the same geometric object. Today we walk through one example writing point, slope from a given point and slope, and one example converting point, slope into slope-intercept. The point-slope form of a line with slope m passing through a specific point x1, y1 is the equation y minus y1 equals m times the quantity x minus x1. The form follows directly from the slope definition applied between the anchor point x1, y1 and any other arbitrary point x, y on the line. Here is the derivation in two lines. The slope between the 2 points is y minus y1 over x minus x1, which equals the known slope m. Multiply both sides by x minus x1 to clear the denominator, and you get y minus y1 equals m times the quantity x minus x1. The result is the point-slope form, valid for any line with a known slope and one known point on it. Step 1 in the workflow. Identify the slope and the anchor point from the given information, whether you have 2 points on the line, or a slope and a point, or a slope and the y-intercept. Reduce the input to a single slope value m and a single anchor point x1, y1. The reduction is mechanical if you have 2 points. Compute the slope first using the slope formula, then choose either point as the anchor. Step 2. Plug the slope m and the anchor coordinates into the point-slope template y minus y1 equals m times the quantity x minus x1. Be careful with the signs of the anchor coordinates. If x1 is negative, the parenthesized expression x minus x1 becomes x minus a negative number, which simplifies to x plus the positive value. Similarly for y1. Sign tracking through the substitution is the most common source of errors in point-slope work. Step 3. Optionally convert to slope-intercept form by distributing the slope across the parentheses and isolating y on the left. The conversion is a couple of algebra steps and produces the equivalent y equals mx plus b form, with b being whatever falls out of the rearrangement. Both forms describe the same line. The choice of which form to leave the answer in depends on what the problem asks for and which form is more useful for the next step of the work. Here is the first worked example. Write the equation of the line with slope 3 passing through the point 2, -1 in point slope form. The given information is exactly what point slope form needs: one slope and one anchor point. Step 1. Identify the parameters. The slope is m equals 3. The anchor point is x1 equals 2 and y1 equals -1. The two parameters together specify the line completely. Step 2. Substitute into the point slope template y minus y1 equals m times the quantity x minus x1. Replace y1 with -1 and m with 3 and x1 with 2. The equation becomes y minus -1 equals 3 times the quantity x minus 2. Step 3. Simplify the y minus y1 expression on the left. Y minus -1 equals y plus 1 because subtracting a negative is the same as adding the positive. So the equation simplifies to y plus 1 equals 3 times the quantity x minus 2. This is the cleanest standard form for point slope. Step 4. Verify by plugging in the anchor point coordinates. At x equals 2, y minus y1 equals 2 minus -1 equals 3. And m times x minus x1 equals 3 times 2 minus 2 equals 3 times 0 equals 0. Wait, let me recompute. Y plus 1 equals 3 times the quantity x minus 2. At x equals 2, the right side is 3 times 0 equals 0, so y plus 1 equals 0, giving y equals -1. The anchor point 2, -1 does indeed satisfy the equation, so the substitution is verified. Step 5. Final answer in point slope form: y plus 1 equals 3 times the quantity x minus 2. The big lesson from this example is the careful sign handling when the anchor y coordinate is negative. Y minus y1 with y1 equals -1 becomes y plus 1, with the double negative resolving to a plus. Watching the signs through the substitution is the single most common error point in point slope work, and the cure is to write the substitution explicitly as y minus -1 before simplifying to y plus 1. The explicit step prevents the sign error that students sometimes make when they try to simplify in their head. Here is the second worked example. Convert the point slope equation y minus 4 equals 2 times the quantity x plus 3 into slope intercept form. The given equation has the structure y minus y1 equals m times x minus x1 with y1 equals 4 and x1 equals -3, but for the conversion we just treat it as algebra and rearrange. Step 1. Distribute the slope 2 across the parenthesized chunk on the right side. 2 times the quantity x plus 3 becomes 2x plus 6. The equation now reads y minus 4 equals 2x plus 6. Step 2. Isolate y on the left side by adding 4 to both sides. The left side becomes y minus 4 plus 4, which simplifies to y. The right side becomes 2x plus 6 plus 4, which equals 2x plus 10. The equation is now y equals 2x plus 10, which is exactly the slope-intercept form with m equals 2 and b equals 10. Step 3. Read off the slope-intercept parameters. The slope is 2, matching the original m in the point slope form. The y-intercept is 10, which we did not have in the original because the anchor point was -3, 4 rather than 0, something. The conversion has revealed the y-intercept as a byproduct of the algebra. Step 4. Verify by plugging in the original anchor point x equals -3 and y equals 4 into the slope-intercept form. Y equals 2 times -3 plus 10 equals -6 plus 10 equals 4. Match. The same anchor satisfies both forms, confirming the conversion is correct. Step 5. Final answer: the slope-intercept form of the same line is y equals 2x plus 10. The big lesson from this example is the conversion procedure: distribute the slope, isolate y, read off the parameters. The procedure takes about 10 seconds once practiced and reveals the y-intercept of any line whose point slope form is given. Going the other direction, from slope-intercept to point slope, just requires choosing any point on the line and plugging into the point slope template directly. The two forms are interchangeable, with point slope being more convenient when an arbitrary anchor point is given and slope intercept being more convenient when the y-intercept itself is the natural anchor. 3 mistakes that catch every algebra student during their first weeks of point-slope work. Each one is fixable with a small explicit habit applied on every problem. First mistake: sign error on a negative anchor coordinate during the substitution step. A student looking at point-slope form with anchor y1 equals -1 writes y minus -1 as y minus 1, dropping the double negative simplification. The correct simplification is y plus 1 because subtracting a negative is the same as adding the positive. The fix is to write y minus -1 explicitly, then simplify deliberately to y plus 1. The explicit two-step sequence prevents the sign error that students make when they try to simplify too quickly in their head. Second mistake: forgetting to distribute the slope to both terms inside the parentheses during the conversion to slope-intercept form. A student looking at y minus 4 equals 2 times the quantity x plus 3 writes the right side as 2x plus 3, distributing the 2 only to the x and ignoring the plus 3. The correct distribution gives 2x plus 6 because the 2 multiplies both terms inside the parentheses. The fix is to write each distribution explicitly: 2 times x plus 2 times 3 equals 2x plus 6. The explicit doubled multiplication prevents the missed distribution. Third mistake: confusing point-slope form with a malformed variant that is structurally similar but algebraically different. A student writes the form as y equals m times the quantity x minus x1 plus y1, putting the y1 outside the slope multiplication, when the correct form is y minus y1 equals m times the quantity x minus x1 with y1 subtracted on the left side and the slope multiplication on the right. The two are different equations and produce different lines if treated as canonical forms. The fix is to memorize the standard form: precisely subtract on the left, multiply on the right, parentheses around x minus x1. The point-slope form is even more common in real applied work than the slope-intercept form because real-world scenarios usually have a known starting point that is not at the y-axis crossing 4 broad sectors below. In physics, the position of an object moving at constant velocity from a known initial position at a known initial time is given by position equals velocity times the quantity current time minus initial time plus initial position. This is exactly the point-slope form, with the slope being the constant velocity and the anchor point being the initial position at the initial time. Every introductory kinematics calculation uses this point-slope structure. In personal finance and accounting, the balance of an account growing at a fixed rate from a known principal is often expressed as principal plus rate times the quantity current year minus start year. The structure is point-slope with the anchor being the starting balance at the start year. Banks, accountants, and investment analysts use this form continuously when projecting forward from a known point in time. In linear regression in statistics, the best fit line can be expressed in point-slope form using any chosen anchor point, often the centroid of the data, which has the average x and average y as its coordinates. The point-slope expression is sometimes more interpretable than the slope-intercept expression because the anchor coordinates have natural meaning relative to the data center. In calculus, the tangent line to a curve at a specific point, a comma f of a, is given in point-slope form as y minus f of a equals f prime of a times the quantity x minus a, where f prime of a is the derivative at the point. Tangent lines are foundational tools in calculus optimization and Newton's method for solving equations, and the point-slope form is the natural way to write them. The skills you build today scale directly into all of differential calculus. 3 things to take with you from this lesson today. Point-slope form is the more flexible of the 2 canonical line equation forms covered so far in this section, and it appears more often in real applied work than the slope-intercept form because real-world scenarios usually have a known starting point that is not at the y-axis crossing. First, The point-slope form of any line with slope m and an anchor point x1, y1 is y minus y1 equals m times the quantity x minus x1. Memorize this template. Write it out explicitly when substituting in specific values, and watch the signs of the anchor coordinates carefully because negative anchor coordinates produce double negatives that need deliberate simplification. Second, the point-slope form is more flexible than the slope-intercept form because the anchor point can be any point on the line, not restricted to the y-intercept point. Whenever you are given a slope and a point that is not the y-intercept, point-slope is the natural form to use. The form is also more natural for physics, finance, and calculus applications where the starting condition is at a specific time or position rather than at zero. Third, to convert from point-slope to slope-intercept, distribute the slope across the parentheses on the right side and isolate y on the left side by adding y1 to both sides of the equation. The conversion takes about 5 seconds and is useful when the problem asks for the slope-intercept form specifically or when you want to read the y-intercept directly from the equation. Going the other direction, from slope-intercept to point-slope, just requires choosing any point on the line and plugging into the template. Coming up next is the lesson called Standard Form, where lines are written in the form x plus by equals c with integer coefficients. Standard form is the third canonical line equation form, and it complements the slope, intercept, and point slope forms with a focus on integer coefficients suited to systems of equations and graphical work.